Hello everybody, welcome to inverse functions. So inverse functions is not really that intense of a topic. The only difference that you really need to know is the fact that we'll go over that. If we have a coordinate xy and we want to find the inverse of this coordinate, which is notated by f negative 1. Note that it's not f to the power of negative 1, it is just the inverse. This is a notation. If we say f negative 1, which is the inverse, we should get the flipped version of the coordinates, which is the inverse of the coordinates. All we did was we took x and y and we just swapped them around to get y and x coordinates. Okay. So all I want you to know as well is that f negative 1 of x is not the same as 1 over f of x. If you're thinking about reciprocals, this is not the same. Okay. So all you're doing is you're taking the xy coordinates and you're just flipping them around. Okay. So let's get into an actual example to see how to actually apply this. Okay. So here's our question. We need to find the inverse of f of x equals negative 3x plus 4. So the first thing that you're going to do is you're going to say let f of x be equal to y, right? Such that what we're going to have is y is equal to negative 3x plus 4. Okay? Because remember, this is the same as the y, obviously, in this case here. And what do we say about inverses? Inverses are essentially when we take the xy coordinates and we just flip them around. So we're going to swap them around in the equation as well. So we're going to just take the y and the x coordinates. So we're going to take the y and the x, and we are just going to do a little swapperoo. And we are going to get x is equal to negative 3y plus 4. Then all we need to do is actually find the real equation here. We can't leave it in the form of x equals. We have to leave it in the form of y equals so that we can get our inverse function. So therefore it will be, when we solve for y, we're going to take that 4 over as negative 4 equals to negative 3y. And then if we solve for y is equal to x minus 4 divided by negative 3. But this is not in the form of an actual function, we know. This is a straight line equation. But we need to write it in the form of y equals mx plus c. So we use our properties that we know about a plus minus c, all divided by b, is equal to a over b plus minus c over b. Okay. And then from here, what do we notice? We're going to have x over negative 3 minus 4 over negative 3. Okay. And if we simplify this further, we're going to have y is equal to negative 1 over 3, because we're writing our gradient now, times x, and x was in the numerator, so we could take it out. Minus and a minus gives us a positive, because remember, these are both negatives. They cancel, and we have positive 4 over 3. And there we go. But our final answer, they said find the inverse. And the inverse is notated as follows. So we can say, therefore, the inverse of f of x is equal to what we just have here, negative 1/3 x plus 4 over 3. Not so difficult, hey? Let's get into actual examples where we have to sketch graphs, we have to find domains and everything. Okay, it's not that crazy. Alright, so here's our problem. It's not a difficult one, but we can still try anyway. And we're dealing with a parabola, so that's why I'm going to introduce you to how to find the inverse of parabolas. Given f of x is equal to 2x squared, I want you to find the inverse of f, sketch both graphs on the same set of axes. What type of function is f? Is the inverse of f a function? Motivate your answer. If f inverse is not a function, restrict the domain to make it a function. Now this is a lot to ask for, but the questions are straightforward. So we need to find f negative 1, which is just the inverse. So therefore for number A, all we need to do is we need to note that we need to let f of x be equal to y, such that what we're going to have is going to be what? Y is equal to 2x squared, because the function they gave us was f of x equals 2x squared. But now we need to find f negative 1, which is the inverse. So all we're going to do is swap the xy around, okay, such that what we have is x is equal to 2y squared. And this implies to us here that when we divide both sides by 2, we have x over 2 equals y squared. I'm going to continue here. Notice that when we take the square root on both sides, then we have plus minus the square root of x over 2, where therefore we can say that, well, not therefore, we can say that y is equal to plus minus the square root of x over 2, and therefore we can say that if negative 1, let me write that a little bit further, if negative 1 of x is equal to plus minus the square root of x over 2. Was that difficult? It was not difficult. Okay. So all we had to do was really just let the f of x be equal to y so that we can flip the x and y coordinates, and then we just solve for y again. And then replace y with f negative 1x. That's all we do for solving for that one. I think it's usually like 2 to 3 marks for those types of questions. The next one, we need to sketch both graphs on the same set of axes. So let's do that. Alrighty, so first things first, we need to know what equations we're working with. We're dealing with y is equal to, so this is the original function. So y is equal to 2x squared. But the inverse function is just going to be y is equal to plus minus the square root of x plus 2. Okay, so right now, what I want you to do for these problems is to take your calculator, or you don't need a calculator, but you can also take your calculator if you want to, okay? And then notice that what we can do is we can find different points on the function. So there's actually 2 ways you could do this. First one, you could use your calculator for both of them. The second method is to take the coordinates and flip them around from the original function. So let's use the second one rather, because the second one is actually nice. So I'm going to change the color of this one. That is not how you change color. I'm going to change the color of this one to blue. Okay, so that the red is the original function and the blue is the inverse. So f of x equals to 2x squared. It's just going to be where the parabola is situated with a turning point at the origin, because there's no y-intercept, it's just plus 0. Then therefore it's also multiplied by 2, so which means the y values are higher, so it'll actually get more narrower. But because I want to show you what the actual shapes look like, I'm still going to do a bit wider. But you should know that it will get more narrower based off of logic. And this is f. Okay. Now what? From here, I want you to find 4 coordinates on this point. And no, I'm not talking about the origin. I'm talking about the fact that we can take 4 coordinates, right? The first 2 must have the same y value, right? So we're finding 2 different x values, which is both negative or positive versions of those. And then we do the same thing for the other 2, but with a different value. So this is how I'm going to do it. I'm going to say at x equals to 1. Okay? At x equals 1, let's say that 1 is here. The output of this function, okay, is going to be what? If we plug in 1 into the function, it's going to be 2 times 1 squared, which is just 2. So our answer will be 2 here. So our coordinate will be 1 and 2. Okay. And then for this one over here, right, let's take the negative version of 1, which is just negative 1. If we take it to our function, notice that the negative 1 squared is just going to be positive 1, so we're going to get the same output at 2. Okay. So this one will just be negative 1 and 2. And then let's take a new x point, but for a different value here. So let's take negative 2 and positive 2. So I'm going to take positive 2, lead it up to the function, and then the output, right, So I'm also going to take, yeah, so the output should be 2 times 2 squared, which is just 2 times 4, which is 8. Okay. And then if I take negative 2 and I take it to the function, it should also go to 8, because if I take the negative 2 into the x, it'll be negative 2 all squared, which is positive 4. And then positive 4 times 2 is also 8. So that is the coordinates that we actually have. Okay, so this one is going to be 2 and 8. This one is going to be negative 2 and 8. Okay, but the question is, how do we find the inverse now? How do we find the inverse function? Well, all we need to do is we need to take the coordinates that we have and we need to flip them. Right? So I'm going to show you the first two that we can flip right now. And I'll take these two over here, and then you'll know what to do with the other ones. So if I look at the coordinate 1 and 2, if I take the inverse, right, like that, this is how you can show it, then therefore we'll flip the x and y coordinates, and we'll have 2 and 1. So therefore, our coordinate will lie at 2 and 1. And if we take 2 and 8, the coordinate like that, and we find the inverse of that, it'll be 8 and 2. So therefore, because in our previous function, our original function, the xy coordinate was 1 and 2, the inverse function will be 2 and 1. So therefore we find those coordinates, okay? So where is that? 2 and 1. So x equals 2 over here. So right over here. And then y equals 1. So it'll be somewhere here. So let's say that 1 is here, and we need it all the way to 2. So the coordinate will be somewhere here. So I want to rather find it in different color. So let's do it in green. So this will be 1. And then it will lead all the way to 2. Okay. And then the other coordinate is just going to be from 2, 8 until 8, 2. So x equals 8 all the way like the side of the world. And then y is equal to 2. And we know y is equal to 2 over here. So we can just lead it all the way from there. Okay. And then we just have our coordinate there. And now we do the same thing with the other one, but we're just going to flip them. So we're just going to do it intuitively. If we flip negative 1 and 2 over, we're going to have 2 and negative 1. So x equals 2 and y equals negative 1. And let's suppose that y equals negative 1 is somewhere here, such that when we take it over to x equals 2, our coordinate will be somewhere here. And then from here, we are going to have negative 2 and 8. We're going to flip them around. It's going to be 8 and negative 2. So negative 2, let's suppose, is somewhere here. So negative 2, and then all the way to x equals 8, because we flip them around. So it'll be somewhere here. And then we just draw our shape that we know. Remember, I don't know if I said it, but essentially the inverse of f is just going to be the same shape, but rotated. So therefore, it's just going to look something like this. So we lead it to the different points. So I want to rather do it like so. Something like that. Okay. It's not the most perfect graph, but hopefully you get the point. And that is f negative 1. And that is not blue, by the way. That's so funny. So which means what I'm going to do is I'm going to pull a lazy move. And I'm going to just make this green. I definitely meant to make it green in the first place, by the way. All intentional. So therefore, we show our points that we've dealt with. This point here is just going to be 8 and 2. This point is going to be 8 and negative 2. This point is just going to be what? 2 and negative 1. And this point here is just going to be 2 and 1. Okay. So there are our points, and obviously it's also at the origin, so we can also write 0, 0 if we want. But that's like optional, since we already have 0, 0 here. Okay. So we just sketched both of them. We showed all the intercepts and whatnot, and yeah, that's basically what we have to really do. So now what's the next question? The next question says, what type of function is f of x? Now, in order to test what type of function it is, we need to first see if it's a function. And we're saying f of x. So let's make up our own vertical line. Let's make it blue. Can at least use the color blue now. Right? If I take this vertical line, right? And I'm going to move this. I'm going to rather use the mouse here. And I'm going to move this vertical line from up to down. What do you notice? It intersects twice. Sorry, it intersects twice, okay, on the function with the vertical line. Am I calling this a vertical line? You know, I read this question and I was already expecting to be a function, so I moved straight to a horizontal line. But I've been calling this a vertical line the whole time. Guys, free me. So this is a vertical line, okay? I hope you understand it now. Okay. So this is our vertical line. So we need to take the vertical line for f, okay? And no, I'm not cutting that out. I want you to see that. It's funny. If we take the vertical line and we go from left to right, what you notice is the fact... Jeez, what on earth is happening over here? What you notice is when we go from left to right, there is no point on this function where the vertical line intersects twice. Obviously, it does touch the other function, but we're only looking at f. And we know it's going to be what? It's a function. So now we use the horizontal line test. Okay? We can finally use a horizontal line now. Like this. And we can take that horizontal line and then go from up to down to see what type of function it is. Because it intersects twice with the horizontal line, this would be a many-to-one function. If it only intersected once, it would be a one-to-one. So therefore, what we notice to answer this question, what type of function is f? We can say here number C. You know what the heck? Number C is f is a many-to-one. Function. Okay. Alright, that's number C. Now what's the next one? Number D says, is the inverse of f a function? Motivate your answer. So is the inverse of f a function? Let's see. This horrific looking function. So we need to take the vertical line test first to see if it is a function, right? So this is a vertical line, believe it or not. I'm going to rather do it here so that I can grab the whole thing. We take this vertical line and we don't shrink it like that. I guess I'm literally going crazy. We take the vertical line, we go left to right on this green function here. Remember, we're taking it for the inverse. And then we go all the way from left to right. Okay. Oh, no. It's intersecting twice with the vertical line. It is not a function. It is a one-to-many, though, if you think about it. So, it's not a function. So there's two ways you could say this. I keep forgetting about the line. Number D says if -1 is not a function because... So there's two ways you can say it. The first way is it fails the vertical line test. Okay. The second way you can say is because f is a many-to-one function, since f is many-to-one, the inverse is one-to-many. Because notice, when we had many x values sharing the same y value, the inverse would essentially mean we have many y values sharing the same x value, and that is not allowed. We can see that one x value shares two different y values, according to our inverse. So that is why it's also not a function. So these are the two ways that you can answer this question. Hopefully that makes sense. Now, what I want you to first do, before we answer number E, what is the domain and range for these functions? The domain of f. What is the domain of f, and what is the range of f? And then what is the domain of f negative 1, and what is the range of f negative 1? First, I want us to figure this one out, because the question number E says, if it's not a function, restrict the domain to make it a function. So we need to find the domain and range quickly. Okay. So, the domain of f of a polynomial function is x exists in all the real numbers. Okay. The range is from where x is greater or equal to 0, because why? It starts from the origin and it goes all the way up. And why did I say x, by the way? What is wrong with me? The range works with y. So y is greater or equal to 0. Sorry about that. But what about the domain of the inverse? Notice it starts from x equals to 0 and it goes all the way to infinity. So therefore x is greater or equal to 0. Let me just move this stuff out of the way. And then for the range, notice that it starts from negative infinity, right, all the way to positive infinity, because it actually goes all the way from negative infinity all the way until positive infinity. So therefore, the range is going to be y is the element of reals. But what do we notice here? Do you notice that the domain of f is just basically the range of the inverse, but notice that the x and y are swapped? And the range of f is basically the same as the domain of f negative 1, the inverse, but the x, y are swapped. Do you notice that the inverse of the range is just the domain, and the inverse of the domain is just the range? So that is the stuff that I want you to know. Okay, just something I would add. Now we can answer this question because you have the information. If it's not a function, which it's not, the inverse, restrict the domain to make it a function. So which means, how is it going to pass the vertical line test, essentially? We need to restrict the domain of f, which is the original function. I don't think I added it there, right? So the actual thing that needs to be added here, restrict the domain. I keep forgetting about that thing, man. Domain of f to make it a function. We need to restrict the domain of the original function, and then the output for the inverse must be a function. So how is that going to be true? So in this case, what makes the inverse not a function? It is many to one. One to many. It's one to many, because for one input, which is x, it gives two different y values. So it's not a function. Okay. So meaning we need to find a way to get rid of a portion such as this arm, or we could get rid of this bottom arm, such that when we do the vertical line test, let's use blue again, then all we are going to do is we need to have a point where it's not going to intersect twice. So how do we do that? When we look at the original function of f, we just need to get rid of one of the arms. Meaning we need to restrict the domain such that the only part of the domain that exists is only one arm of the parabola. And what does that tell us? When x is less than or equal to 0, then we only have this region. Does that make sense? And when we take the inverse, it should be a function. But if we say x is greater or equal to 0, we're going to have this arm. And if we take the inverse, we're still going to only have it being 1 to 1. Okay, the inverse of a one-to-one function is just a one-to-one function. I hope you understand that, at least. The inverse of a many-to-one is just a one-to-many, which makes it not a function. So therefore, we need to make it one-to-one. So that is why we restrict the domain. So there's two ways you could do this. You could either use, so for number E, either you could restrict domain of f to x is less than or equal to 0, so basically the left part of the arm, or you could restrict the domain of f to x is greater or equal to 0. Okay, so those are the two different things that you can do. Okay, so you would say, so as an actual answer, by the way, new domain f equals 2, or you could say restricted will be equal to x is less than or equal to 0, or new or restricted df would be x is greater or equal to 0. So that is how you could answer this question. And that is inverse functions. It's not too terrible. Just I made a little bit of silly mess ups, but hopefully you understand how we are supposed to do all of this stuff. Okay.